Hi, I'm Mr. Robinson, and I'm going to provide you some assistance to complete the unit, the real number system. So this unit focuses on using the Pythagorean theorem. By looking at your rubric, the first thing you would have to do is to explain the relationship between the legs and the hypotenuse of a right triangle. And so when we talk about relationships, you're like, is one smaller? Is one larger? Are they equal to each other? And so with this scenario, we have to go a little bit further and than just describing which one's larger or smaller. This relationship is squared here. And so here's a triangle ABC. A and B are the two legs that form a right angle here. But the Pythagorean theorem states that in any right triangle, a squared plus b squared is equal to c squared. And this is information that you need to put down to discuss the relationship of, of the legs and the hypotenuse of a right triangle. So after you use that information to discuss that, then you got to draw a diagram to represent a real world situation, solve for missing length, and write an equation to represent a real world situation. So with that, we're going to have a little fun with these tools that you have in access to use. Right. So this question, it says the building meets the ground at a right angle. The top of a 10-foot ladder is placed against the bottom edge of a window in the building. The base of the ladder is placed 6 feet from where the building meets the ground. I'm going to draw a similar problem to help you figure out how to do this. And so let's imagine you've got a tree in the backyard and you have a branch that's high and you can't really measure it. But if you have a ladder and a tape measure, you can figure it out. So let's say here's a tree branch. So it goes down to a tree. Continue this tree up. And if you lean your ladder up against that tree, you have that. And let's say that's a 12-foot ladder, 12 feet long. But you can measure how far that base is to the base of the tree. And let's say this is 8 feet. Okay, if that's the case, and then this is x, we want to figure out how big x is. Well, lo and behold, look, we have a right triangle here with the length of that ladder, the base here, and then the height going up. And so now we can use that Pythagorean theorem to be like, to figure out what x is. So 8 squared plus x squared is equal to 12 squared. Right? And so we can use your little calculator over here to figure out some of these calculations. 64 is what 8 squared is. That's 8 times 8 plus x squared. It's equal to 12 squared. 12 times 12 is going to be equal to 144. If you're not aware of that, you can use your calculators for that. Now this is going to be the 64 plus what is 144? Well, find the difference here. 144 minus 64 is equal to 80. So x squared is equal to 80, but we want x, right? We don't want x squared. So we're going to have to take the root of 80 to get x. So x is equal to the root of 80, which is an irrational number. So we have 8.94 before it continues on. Right, so that's how you're going to answer this question, do a similar process. Now, down here, you're going to have to figure out the height of that window. And here you have a situation where you've got two numbers of the Pythagorean theorem. So use a Pythagorean theorem to figure out, okay, is this one a leg? Is that a leg? Is this a hypotenuse? And that a leg? And then figure out which one of these would fit that equation to figure out how high Joe climbed. And the final one here, this has been difficult with students. You want to figure out the longest item that can be placed in here. And so notice that this is a hypotenuse of this triangle here. This is 24 inches. This one is 12. And so use this information, figure out the length of that. The problem is they want you to answer it in this m root n thing. And so and that's going to be hard for you. If you guys give me an irrational number, like the root of whatever that is, and put that in there, I will accept that. good luck with this, and please let me know if there's anything else that you guys need.